So today we're going to continue our discussion on time series modeling. In particular, we are using ARIMA modeling. So last time we began the introduction to time series. So let's make sure that these packages are loaded. Okay, so let's quickly review what we have discussed so far. Okay. I think we covered quite extensively some materials. Okay, we said that we're going to make use of the Box-Jenkins approach in order to model time series. So the Box-Jenkins approach uses what we call the ARIMA model, autoregressive integrated moving average. By way of review, we said that AR refers to modeling our time series using its past values, and MA is modeling the time series using the past error terms. Okay, I here stands for, so this is integrated, or this means that we are using not the original data, but the difference data. When you say difference, you subtract the value now to the value yesterday, so you have a new series now. Okay, it's different from the original series because this series is now has, let's say your original series has 100 observations. Now it will only have 99 because you're you're getting the difference. Okay, so we said last time that an AR1 process is simply regressing your or modeling your time series y sub t based on past values. Okay, log 1 value y sub t minus 1. Right, so this is your model. A null, this is the average, this is the mean, plus the coefficient of the log 1 value, A1 times y sub t minus 1, plus a certain random error, E sub t, where E sub t is white noise. Okay, now we said that if the model has a coefficient of 1 for A1, then it's a random walk. An AR model should have a coefficient that's less than 1. And then we also describe what the other ARIMA models are. AR2, in general, ARP refers to a time remodeling or time series using P past values. Okay. For moving average, we use the log 1 LAG, no? Log 1 log 1 error term. Okay, so an ARMA 1.1 model is modeled as a average, a null plus A1 multiplied by 1 log 1 past value, okay, plus your MA component, which is error, plus B1 times epsilon log 1 error term. Okay, so we said that in order for us to use the ARIMA model, we have to make sure that our time series is stationary. And what does a stationary time series look like? A stationary time series looks like a series that has no plot, no trend, nor seasonality. Okay, and we said that we have to convert our time series into a stationary time series. Why is this so? Because a stationarized series is easy to predict. Okay, mas madaling i-predict yung stationary time series. That's the assumption, that's the requirement in order to model it using ARIMA. Kailangan yung ano natin, yung time series natin stationary. Okay, so for example, we looked at this data ng air passengers. Okay, let me call that AP. Okay. And then ipa-plot na lang natin ang diretso kasi we already did this before. We already studied this before. So here I have this object AP. Okay, AP, and it's the air passengers data. And then I'll just plot it. I'll plot here. Okay, so here we can use the plot function. Okay, so okay, this is the plot of our time series. Now we can say that this is a trend. It's going up, and this is seasonality. There are specific times when the value goes up and goes down. So there's a pattern to this. So this is not non-stationary time series. So if we're going to use Box-Jenkins approach, we have to convert this into time series, which we're going to look into in a while. Okay. So let's go. A time series can be decomposed. Okay, we can use the see here we're creating an object called decompose. We're using the decompose function from the stats package, and then we plot it. This is just a review, guys, of what we discussed so far. Okay, that's why I'm going through the codes. Okay, while we're waiting, guys, it's taking time. Medyo mabagal yung ano ko ngayon, yung computer. Okay. And we can test, aside from just a visual inspection, we can test our time series if it's stationary or not, not stationary. Okay, it's taking some time. This gives us a plot of the decomposition of our time series. Because our time series has trend and it has seasonality. So when we decompose it, it will show us the trend component, the seasonality component, the original data, of course, and the irregular component. When you say irregular, these are the components of your time series that cannot be uh, that cannot be classified as a trend or a seasonality. Okay, it's taking so long. Okay, let me just okay, let me run this one more time. Okay, I hope it runs now. Anyway, guys, let me just, I hope you were able to run that. Escape ko na kasi. Okay, then as I was saying, we can, it's not only visually that we're able to determine if it's stationary or not. Although it's usually very easy to determine if your time series is stationary or not. But here we have, for example, we can use the augmented Dickey-Fuller test in order to statistically test if our series is stationary. The null hypothesis here is that the time series is non-stationary, and of course we would want the p-value to be less than 5% so that we reject this null hypothesis. Okay, so here this is from the package T series. Okay, we use the ADF test. We're subjecting our object AP into an augmented Dickey-Fuller test to check if it's stationary or not. Okay, let's click this. Okay, then we have this result. Okay, it's 0.78. So we reject the null hypothesis that we fail to reject our null hypothesis that it is non-stationary. Okay, so our data, as confirmed statistically, it is non-stationary. Okay, so let me see. Okay, we said that in order to determine also if it's stationary or not, we use the autocorrelation function. We plot the data, we plot the ACF autocorrelation function and the partial autocorrelation function. Okay, if a time series is not stationary, then it means that there will be no significant correlations among the series, among the data. Okay, so we expect that if it's stationary, there should be no. If it's stationary, guys, okay, it can be determined using the ACF and the PACF. Okay, let's take a look at that. Okay, here we're using ACF and PACF. Okay, so here it's a separate plot for ACF and ACF. However, guys, we can use the AC function. Okay, so let's see, AC autocorrelation function. Okay, I wonder why my R is processing so slowly. Tagal. Okay, anyway, when we plot, guys, so this is from the TSM package. The AC function will plot both the ACF and the PACF at the same time. Okay, dati kasi, dati, nung wala pa AC function, separate natin kinukuha. No? We plot the ACF and the PACF separately. Okay. ARIMA.symptom. Okay, here. AC, guys. Autocorrelation and partial autocorrelation function. Okay, so this is from the TSM package. All right, so we can see here, guys, the ACF and the PACF. So one indicator that the series is not stationary if you have a very slow decay here. Here, you have a very slow decay here, either in the ACF or in the PACF. So we were able to show using ACF and PACF that the series is not time series, it's not stationary. Also using the first we look at the plot, no? Plot ng AP. It has a trend, it has seasonality. So therefore, it's not stationary. We also looked at the PACF and the ACF. In the ACF, it's slowly decaying. So that's an indicator that this is not stationary. And also we used the augmented decay Fuller test and came up with the conclusion that indeed this is not stationary. So we cannot use, guys, we cannot use ARIMA if the series is not stationary. Okay, I'm sorry, guys. I think there were I made some adjustments, no? So could you kindly go to that? Anong row number yung magsa-simulate tayo ng ng AR and AMA time series. Could you kindly look for that kasi nag-iba-iba yata yung rows ko dito, no? But it's supposed to be around 200. Okay? We're going to use the ARIMA.sim. So this is simulating an ARIMA process. Okay, have you seen it? Paki-chat naman please kung nakita niyo yung okay, fourth, welcome Chadwick, welcome, thank you for coming. Kindly take a look, guys, kung saan anong row number tong yung ARIMA.sim. We're simulating an ARIMA model. I'm very sorry, guys, kasi parang na-rearrange ko yung numbering ng codes. Could somebody please? Around what row number? 222. Okay, thank you, Matthew. Okay, so around that, no? Siguro, sige, ano ko na lang din, i-position ko there.
Sir, sa akin dun sa 222, wait. Dun sa 222, walang ARIMA SIM.
Ano yung, pakihanap na kung saan yung ARIMA SIM. Thereabouts yun, mga 200 plus. Sorry, medyo nagbago na yung ordering. A1, ARIMA.sim, model, AR is equal to 0.8. Nakita mo fourth?
So yung pinakaunang ARIMA SIM na nakikita ko dito parang 330. Pero titingnan ko yung iba.
330?
Yes sir, yung ARIMA SIM. Wait lang. Titingnan ko yung sa taas.
Sige, pakitingnan, no? Okay, so habang hinahanap ni fourth, well, yung code natin, set.seed, no? 1, 2, 3. Okay, we're using this, yung set.seed na to, so that we have the same figures. Kasi magsa-simulate tayo. Magsa-simulate tayo ng mga data points nito so that yung time series natin could be modeled as an ARIMA model, okay, with AR is equal to 0.8. Ano ibig sabihin ng AR is equal to 0.8? That's the coefficient of our model. No? Yung model natin will be bali y sub t is equal to 0.8 times y sub t minus 1. So we're multiplying this to the log 1 ng past value niya. Okay, nakita mo na? Fourth?
Sir, dito sa may 215, AR.mods, tapos may ARIMA SIM na kasum. Hindi siya A1 eh.
Hindi pa yan. Baka sa ilalim yan.
Okay. Wait lang sir.
I think sa baba niyan. Yung AR.mode kasi linipat ko kanina, sorry kasi mukhang hindi tama yung order ng yung AR.mode, linagay ko dito sa sa bandang baba, no? Ito yung sinasabi mo fourth, nasa Nalagay ko na sa 300 to eh. Okay, very sorry about that. Kasi ang karugtong niyan dapat yung itong pagpa-plot. I don't know why nagulo-gulo yung order.
Sir, wala akong nakikitang A1
Wala.
na may
O sige,
ARIMA SIM sa may
kopyahin mo na lang
200
to.
na lines.
Kopyahin mo na lang, kopyahin mo na lang fourth, no? Chinat ko.
Okay, sir.
Chinat ko para mas mabilis. Mag-insert ka na lang ng panibagong chunk. Okay. All right. So we're setting the seed at 1, 2, 3. Again, random number yung kahit 1 yan o 2, kahit anong number yan, no? Ang ginagawa niyan para pare-pareho tayo ng ng values. So we're creating an object called A1 and it's an simulation of ARIMA. Ang model natin AR is equal to 0.8 tapos 1,000 data points, no? Okay, so pwede nating i-view, tanggalin na lang natin tong and then plot natin. Okay, plot. So ito na yung mga values, no, yung simulated values ng time series natin. So yung unang value sa akin, negative 2.3438. You should have the same. No? Kindly check guys if you got the same first value. 2.3438. Pareho ba tayo?
Sir, I got negative 0.03.
Ha? Negative 0.03? Yung iba,
Same naman, sir, sa akin.
negative 2.34.
Yes, sir.
Sino nagsalita? Si Matthew? Matthew, ikaw ba?
Yes, sir.
Did you run set that seed?
I'll run it again, sir.
Run mo siya, tapos isabay-sabay mo na, no? Baka hindi mo na run yung set that seed.
Yes, sir. Still same.
What do you still say?
It's still negative 0.03.
Ganun ba? Bakit? Negative 0.03. You're running ARIMA.sim model is equal to list AR is equal to 0.8. Ito mismo?
Yes, sir.
Wow, weird, huh? Surprising. How about yung iba? Are you running it? Janine, rin-run mo pa siya?
Yes, sir. Yes, pa, sir. Wala pa siyang lumabas. Wait lang po, sir.
Wala pa, hindi pa lumalabas. Ba't kaya ganun? Kasi kay fourth pareho kami, negative 2.3438. Okay, I'm wondering why. Dapat it should be the same eh. Kasi simulation to, no? It's a simulation tapos we're setting the seed at 1, 2, 3. Ibig sabihin pare-pareho tayo dapat ang values niya. Okay, anyway. So pag plinat natin yung A1 natin, what do you notice guys? Does this have a trend? May trend ba to? Wala, di ba? May seasonality ba? Oo, wala rin. So, is this stationary? Yes, this is a stationary model. This is a stationary time series. In fact, AR1 to. No? Paano natin nalaman na AR1? Kasi, sinimulate lang natin to eh. No? Ginamit natin yung AR is equal to 0.8. Take note guys sa AR1 model, the coefficient, yung phi1, okay, should be less than, the absolute value of that should be less than 1. So hindi pa pwedeng 1 and above. Okay, yan ang limitations. Otherwise guys, pag naging 1 yan, mag-explode yung data natin, hindi na magiging hindi na siya magiging stationary. Okay? All right. So we can check guys, let's check the autocorrelation function, autocorrelation and partial autocorrelation function ng A1 model, ng A1 data natin. Okay, and then we will see that, okay. So here guys, pag A1, pag ARMA guys, ang tinitingnan natin yung PACF, no? So sa ARMA, sa AR model, not ARMA, sa AR model guys, yung PACF, it's significant at the first lag, and then yung ACF niya, it's a slow decay. Yan, tingnan nyo dito, slow decay siya. Tapos significant siya dito at lag 1. In fact, kung titingnan nyo, 0.7 something. Okay? 0.7 something, di ba? Ang ano natin, model natin, 0.8, di ba? So, halos 0.8 siya. No? Halos hindi siya exact. No? Kita nyo dito. Okay, so yung correlation niya sa una is 0.7. So yung value natin at time t is correlated at time t minus 1 at around 0.7, 0.8, no? 0.8, which is really the model, no? So we can see, guys, that we're able to determine if it's an AR model via the PACF. Now, dati yun talaga ginagawa namin, no? Para malaman namin kung AR model siya o MA siya, ipa-plot talaga yung ipa-plot yung PACF at saka ACF. And then doon i-determine mo AR ba to, MA ba to, ARMA ba to, which was quite difficult, no? Kaya ano siya, trial and error. Trial and error method siya. Ang hirap pa naman pag trial and error. So it was really quite a challenge before. Ngayon guys, with the advent of statistical packages, ang dali na malaman kung anong model ba yan. Ito na guys yung pag-determine natin ng model. So fourth, wala ka nito?
Sir, meron, ARMA 10 wala po.
Wala. Baka tingnan mo ako nasa baba.
Ang nakita ko kanina sa may bandang 300 parang A11.
Okay, sandali lang ha. Save ko lang siya. Tapos, i-ano ko na nga. Save ko to. ARIMA model class 1. Tapos, i-share ko na lang dito para so that you can use it. Kasi, mahihirapan tayo kung time series. Okay, ito. Send successful. Okay. Fourth, yan, na-send ko na siya. You may wish to open that. Tapos siya nang gamitin mo para the others also if you want to use that. Para pare-pareho tayo ng ng positioning.
Okay, sir.
Okay. Sige, let's give also guys, you might wish to download that para pare-pareho tayo ng ng I'll give you a few seconds, guys. Pag ready na kayo, please tell me. Pause muna ako. Okay, I'm at row 233, no? So dito, how do you model now? Di ba may may data series na A1. Ano yung A1? Balikan natin ha. Yung A1 guys, yung nag-simulate tayo ng time series. A1. Okay? So ito yun. Ito yung time series natin. This one. Tapos, ano ginawa natin? I-model natin ngayon. Tingnan natin kung ano yung model niya. Dito pa lang sa ACF, guys, makikita mo na no? Ito yun, no? Yung correlation ng first lag. So this is your phi1. So around 0.7, around 0.8. Okay, yan yung model natin. So your y sub t is equal to around 0.7 times around 0.8 times y sub t minus 1. Okay? And expected yung kasi nag-simulate tayo, yun ang ginawa natin 0.8. Pero syempre, pag simulation, hindi naman eksakto yan. Okay, so let's determine that now. We use the ARIMA function ito. Okay? So dito guys, tayo magsasabi, no? Kung kung ano yung model na gusto natin. So ito, order is equal to C, P, D, Q. Ano yung P? That's the log of the AR model. No? This one is MA. This one is kung may differencing. Okay, so hindi naman natin dinifference yung data natin. Okay, so we're going to use this, try to see if this is a good model. Okay, and then i-print natin yung ARIMA 10 natin na model. Run natin to, guys. Run. Okay. All right. So here you can see, guys, ano yung model natin if AR1, there, the coefficient is 0.7783. Yan. So ang model natin, y sub t is equal to 0.7783 times y sub t minus 1. Okay, di ba? Ang AR model natin, auto-regressive, you're regressing it against past values of itself. No? AR1 model means the log 1, LAG1. So that's 0.7783 times y sub t minus 1 plus a certain error term epsilon sub t. Okay? So, yan ang binigay sa atin na model. No? Okay, and then, you have to check, guys. No? You have to check. By the way, guys, meron tayong tinatawag na auto.rima. No? Ito nga, i-ano natin to, i-copy natin to dito. Control C, Control V. There. Auto.rima. Tapos pwede natin ilagay, guys, trace is equal to T. Ibig sabihin ng trace is equal to T, magbibigay siya ng ibang models pa. And then it will determine kung ano yung best model. So that function is auto.arima. No? So auto.arima, mali ito, no? Auto.arima ng A1 object natin. Okay, so sorry about that. Dapat A1 to. Ang minomodel natin, guys, yung A1. So pinapahanap natin kay R, ano yung automatic niya hanapin kung ano yung magandang model for A1. Trace is equal to 2, ibig sabihin maglalagay, hahanapin niya yung iba't ibang klaseng model. So let's run that. It will give us different suggestions. Okay, ayos guys, hindi auto.arima ARIMA 10. Yung ARIMA 10 is already the model, no? So we're asking R, paki-model nga yung A1, pakihanap kung anong pinakamagandang model dyan. So nag-a-approximate siya, gumagawa siya ng approximations. Okay, let's wait for that. And then while waiting for the answer, guys, we're just going to take a look at what, okay, yan na. Okay, so take a look at this, guys. No? Ano lumalabas dito? Nag-identify siya ng iba't ibang klaseng models. No? So number 1, ARIMA 202 with non-zero. Ito yung AIC niya, yung AKIK, no? 2851, etc. May ARIMA 000 nga, which is actually white noise. No? Sinasabi niya, baka white noise tong A1 na to. With non-zero mean, tapos with zero mean. Yung iba, guys, non-zero mean. Yung iba, zero mean. Ibig sabihin may idadagdag na constant. Pag zero mean, walang constant, wala yung A sub O. No? Alright, so it turns out, sabi niya, that ARIMA 100 is the best model. No? It's the best model with the lowest, ito yung lowest na AKIK, 2848.996. 2848, parang mas mababa to. I wonder why 2848, pero ito 2848.817. Pero bakit sinasabi niya mas mababa itong ARIMA 11? Okay, first time ko lang na-encounter to guys na 2848. Sorry, so ito pala, no? So mali ito. 2846.909. Diba? Surprisingly, parang mali yung sinabi dito, ano? Kasi ang ARIMA 100 with zero mean is 2846.909, and this is the one with the lowest AIC, no, information criterion. Ito ARIMA 100 with zero mean, bakit 2848.996? 2848.996, wala naman dito 2848.996. Anyway, nagkamali siya dito, no? So it's 2846.909, siya yung pinakamaliit na na AIC, no? So the best model guys is ARIMA 100. Okay, ito yung AR component niya, AR1 component 0.7783. Okay? So with technology guys, ang dali nang gawin ngayon, no? Dati pahirapan kami na nag-ARIMA modeling kami. Ngayon, Auto.ARIMA na lang, tapos bibigyan pa tayo ng ano. In fact, mamaya gagawa pa tayo ng, expand pa natin tong Auto.ARIMA na to, tapos it will really give us more choices, no? Okay, so our model for that is AR1, which we expected kasi yung data natin, sinimulate lang naman natin siya, di ba? Sinimulate lang natin siya. Okay, now, ano yung laman ng ano? Yung nag-ARIMA tayo kanina, di ba? Ang ginawa natin, we created an object called ARMA 10. ARMA 10. So let's see, ano ba yung laman ng ARMA 10 na yan? Okay, so let's see, let's run this, names ng ARMA 10. Okay, so andyan yung coefficient, yung AIC niya. Okay, and then interested tayo dito sa residuals, no? Residuals, kasi kunyari, tingnan natin ha, ARMA 10, COF, no? Their coefficient. Pag rinan nyo yan, it will give us yung coefficient ng AR1 natin. Okay? So dito ang gusto natin, kunin natin yung ano, yung ARMA, yung residuals, yung error terms. Okay? Kasi kunyari, lagay natin dito, no, view ARMA 10 residuals. This will give us the error terms ng model natin. Yung error terms natin, guys, is the difference between your actual value and the model value. So ito yung mga error terms natin. Now, remember guys, importante na i-check natin yung residuals. We will diagnose our model. Okay ba yung model natin? Let's check the residuals of the model. Kaya yung assignment nyo guys, yung take-home quiz nyo, which group na lang, mag-model kayo ng time series, dalawang series, no? One is to be assigned to you, another one is kayong hahanap ng time series pero ipapa-upload niyo sa akin. Okay, I'll give you 1 week for that, due next Friday. Okay? Imo-model niyo siya. Pag minodel niyo, you will identify ano yung best model, i-write niyo yung model na yon, and then i-diagnose niyo kung okay yung model. Okay? In terms of residuals, autocorrelation, etc. So ito guys, ARMA 10 residuals. Let's see, asan yan? Okay, i-plot muna natin siya, no? Okay. So this is our residuals, no? So stationary siya, di ba? Okay? Constant mean, constant zero mean, and then constant variance. Constant variance siya. Okay, so which means okay yung residuals natin, okay yung model natin. And then what we're going to do is, tingnan natin yung autocorrelation function niya. Let's run that. Okay. All right, tingnan nyo guys, no? Tingnan nyo. Okay, this is white noise. So yung error terms natin dapat white noise. Pag may mga lumalampas dyan, ibig sabihin nun guys, hindi white noise yun. Ibig sabihin, we have to do something about it. No? Okay, we have to do something about it. Kasi may mga ano pa, may mga significant pa. Okay, so ito, looks good. Our model, the residuals of our model is white noise, yung epsilon sub t na yan. Okay, so how do we write now our model? Diba, pag isulat natin yung model, so that will be AP, okay, AP as a function of t is equal to, so zero mean, di ba, sabi? 0.7783 times, okay, AP t minus 1. T minus 1 plus a certain error term. Yeah, that's our model, guys. And where ET or epsilon sub t is a white noise. No? Kitang-kita natin, guys, yan yung white noise. No? Yan. Okay, in fact, guys, ito tingnan natin Okay, ito pala, linagay ko dito. No? So, ilagay natin to guys sa isang chunk. Copy na lang natin to. Control C, Control V. Model the residuals. What if we're going to model the residuals? Okay, so let's create a let's create an object, residual ARIMA 10, and that's the residuals of ARIMA 10. No? So binigyan natin ng pangalan, res ARMA 10. Okay, and then let's model it auto.arima res ARMA 10 trace is equal to true. So let's run this. Tingnan natin kung ano yung model ng ano yung model ng res ARMA 10 natin. Okay? And here we can see, guys, that tingnan nyo. Ano daw yung model ng res ARMA 10 natin? It's an ARMA 00. So walang AR component, walang MA component. With zero mean. Kasi white noise na nga siya. Ganyan yung white noise, guys, no? ARMA 00, ARIMA 00 yan. Okay, which is this one. 2846.057, that's the lowest akaiki. Okay, so nakita natin, guys, na yung residuals natin, when we modeled our 8P, AP1, okay na siya. No? Okay, tingnan naman natin, guys. Okay, let me see. What if tayo dito, what if we modeled AP1 ba? Anong object natin? A1 pala, A1. Asan na ako? What if we modeled A1 as an MA, as an MA1 MA1 as ARMA 001. Okay. Okay. Let's assume, guys, binigay ko sa inyo yung A1 na time series. Tapos, tapos sinimulate ko lang. Pero kayo hindi nyo alam na sinimulate ko yun. Okay, tapos tinignan nyo yung you looked at the ACF, the PACF. Okay, you looked at this, and then nagkamali kayo. Ang nasabi nyo, ay, MA yan, MA1 yan. Okay, kasi pwede tayo magkamali pag tinignan natin to, di ba? So you said, ay, MA1 model to. So na-confuse kayo. You were looking at, akala nyo pag significant at 1 log sa PACF, you thought that it's an MA1 model. So tingnan natin. Let's just try. What if this was modeled as MA1? So what will be our code, guys? Ano yung code natin? Remember, ARIMA yun, di ba? Ito. Ito guys, no? Ito. So let me just copy this, Control C. So I'll just call it ARMA 10X, no? Ibig sabihin, nagkamali model natin. So we're modeling A1, pero it should be now 0, 0, 0, 1, 1. Okay, 0, 1, 1 na siya, no? So ARMA 10X, we're asking R to model it ARIMA order 0, 0, 1. Okay, run natin. And then ARMA 10X. Print natin. Okay. So we have here an MA component, no? 0.6168. 0.6168. But the AIC is 3211.71. So kung i-compare mo yon to the AR1 model natin dito, where the AIC is 2849, no? 2849 yung AIC natin dito. Sa kanya, ang AIC 3211.71. Ibig sabihin guys, no? Mas maganda yung ano, yung mas tama yung AR1 na model. Okay, in fact guys, sino natin yung ano nito, yung AC ng ARMA 10X. Tingnan natin yung ano, yung yung residuals niya. So here guys, maximum log natin, gawin natin 18. So let's create the autocorrelation function ng ARMA 10X. Sino sa ARMA 10X? Ito yung minodel natin sa A1, si A1 using MA. Pero alam natin na AR yun, di ba? Pero subukan natin gawing MA siya. And then let's see. Ano yung autocorrelation function niya? Tingnan nyo guys, look. O ito yung residual siya. O ibig sabihin guys, hindi pa white noise to. No? So hindi natin na-capture yung mga significant values dito. So that's what this tells us, no? In fact, ipa-auto ARIMA natin to. Auto.ARIMA, no? Auto.ARIMA si ARMA 10X. And then let's see, trace is equal to 2. Okay, what are we doing here? Di ba nag-create tayo ng ano, ng, wait, sandali. Auto.ARIMA, mali. Dapat yung residuals. Okay, we created an object called ARMA 10X, no? Si ARMA 10X yung model na yan MA. Tapos ang ginawa natin, kinuha natin yung residuals niya. Ipa-model natin, tingnan natin kung, kasi ang lumalabas sa ano guys, sa autocorrelation function, hindi siya white noise, no? Yung residuals hindi. Ibig sabihin hindi yung residuals hindi the residuals guys should be white noise so that wala na tayong pwede ma-extract na model doon. Here it's not white noise. So let's see, baka may model pa yung residuals ni ARMA 10X. Let's see. Okay, tingnan nyo guys, yun. Bumalik dun sa ARIMA 2. No? Naging ARIMA 2 na nga eh. So we have an AR1 process and an AR2 process. Okay, so that's what happens guys when we misclassify the model, no? When we are wrong in modeling it. So anong nangyayari, yung residuals natin hindi homoscedastic, no? Hindi white noise. Okay, and dito lumalabas guys yung residuals, pwede pang ma-model ng ARIMA 20, ARMA 20. No? Ano, may AR1 component, may AR2 component pa. Okay, so that's what happened guys when we model the AR1 process as an MA1 process. Okay, clear ba so far guys? Clear so far?
Yes, sir.
Okay, good, good. Janelle, welcome. All right. Mag-ano naman tayo, mag-simulate naman tayo ng MA model. Okay, so I hope guys, ito mas nagiging clear sa atin yung AR model, yung MA model reminder. Guys, just to recall, an AR process, guys, you model your time series based on past values of itself, no? Y sub t, based on y sub t minus 1, y sub t minus 2, etc. For example, ito yung A1 model natin. Ito yung A1 data natin. Okay, in order to model this time series, dinirelate natin yung, kunyari, itong y sub t na to with the past value. Related siya dito sa y sub t minus 1. Okay, so y sub t minus 1 related siya sa y sub, pero isa lang, no? Isang lag lang yung sa model natin for A1. So we're just relating yung y sub t natin to the past value. So itong 0.621 na to, relate natin dito sa previous value niya, etc. Okay, MA naman guys. So once again, we simulate. Model natin is equal to, ilist natin na si MA is equal to 0.6, 1,000 ulit. And then let's plot. And then kunin natin yung autocorrelation function. Ikliran natin. So this is, we expect this to be stationary, no? So this is an MA1 process, stationary siya. And the autocorrelation plot, pag MA guys, ang tinitingnan natin is the ACF. Okay? So ACF, makikita natin dito guys, significant 0.4 something, no? Which we expected. Okay, tapos yung PACF niya, slow decay din. No? Slow decay. So this is indicative that this is an MA model. All right? Chat. Okay, thank you, Matthew. MA model siya, no? Okay, sige. So, i-ano ulit natin, guys. Hanapin natin kung ano yung model niya. So, based on ACF, nakita natin that there's a significant spike at lag 1. In fact, nakita natin na yung value niya around 0.4 something. No? And on hindsight, alam natin na mga 0.4 yan kasi sinimulate lang natin yan. No? Okay, so here, ARIMA, yung object natin M1, order 001. No? And then we have it printed, ARMA 01. Run natin to. Okay, take a look, guys. 0.5838. Yung simulation natin, 0.6. So, pretty close. So, ARIMA 001, okay, MA1 component, 0.5838. So, how do we write our model? Our model is, okay, MA1 sub T, no? Is equal to error term plus, guys, ang ginagamit yung minus 0.5838 times error t minus 1. Yeah, that's our model. No? So our M1 model, M1 T sub T is equal to epsilon sub T minus 0.5838 times epsilon sub T minus 1. So we are multiplying the to the past error term. No? Okay. All right. So again, let's plot natin yung residuals. Dapat yung residuals, guys, walang trend yan. Yan, walang trend, walang seasonality, mukhang constant naman yung variance niya. Okay, and then let's let's once again get the autocorrelation of our ARIMA 01 model ng residuals. No? Okay. Okay, medyo may konting ano, no, may konting spikes dito sa ano, but generally guys, halos white noise siya. No? Yung lag, ang layo naman eh, no? Ang layo naman, so we can accept this. Looks like yung ano natin, practically white noise. Okay? Of course, guys, di ba pwede nating matest kung test for seasonality, stationarity yun. Ano. Okay, ito guys, I'll leave this to you guys to explore. Alam natin yung M1 natin, it's an MA process, pero ito minomodel natin siya na AR. Okay? Ganun din sa ginawa natin kanina. Sige, run na nga natin. Dito na. Okay, so you have here, minodel nga siya as an AR function, 0.4111 with the AIC at 2923. No? Yung sa ano natin, sa MA process natin kanina, okay, ito. Okay. 2825. yung kaiki information criteria niya dito, 29.23. Okay, so here we called it X. Okay, ganun din guys, kung kunin natin yung ano, yung autocorrelation function ni X, yung residuals niya. Okay. Same thing guys, no? So may mga significant spikes siya, which means that your error terms, your residuals is not homoscedastic. Okay, it's not even stationary, no? So ibig sabihin may mga hindi ka na-capture. Doon sa process natin kanina, yung sa time series natin, na in AR1 natin, yung model natin was not able to capture yung ibang movements, no? Kaya nga yung ano natin, yung plot ng AC natin, turns out na may mga significant spikes pa. So which means na hindi acceptable yung model na yun. Since there are still significant lags. Okay, so another example. I hope you're getting the hang of this, no? So let's set naman an ARIMA 11. So si ARIMA 11 guys, ganun din ARIMA.simulation. Gawin natin tong ano, let's call this ARIMA 11. ARIMA 11. So let's see para mas ano yung pangalan. Okay. So we're simulating this model. We will have to list the AR component 0.4 and the MA component 0.5. Okay, plot natin and then get the autocorrelation function ng ARIMA 11 natin. Okay, so si ARIMA 11 guys, stationary siya, kitang-kita natin, no? So tapos yung ano niya, yung ACF at saka PACF. So walang mga significant ano siya, slow decay, no? ACF and PACF are both slow decay. So ibig sabihin yan guys, ano, ARIMA ano to, ARIMA time series to, no? Okay? So ang ginawa ko dito, i-auto.arima na natin, no? Pa-model natin. Okay, auto.arima. Auto.arima yung yung ARIMA 11 ano natin, 11 time series. And then let's trace So trace natin is equal to true. Okay, so let's see anong model to. Auto.ARIMA. Then si ARMA 11 object natin, yung time series natin na consisting of still running. Okay, so we now have yan. Okay, so although ARMA 11 yung ginawa natin, lumalabas dito na ARMA 2 yung best model with zero mean. Okay, so let's compare yung ARMA 11 to, no? ARMA 11 with zero mean 2837, ARMA 22 with zero mean 2836. Oo nga, no? Mas mababa yung ACAIC information criterion ni ARMA 22. Okay? So even if guys simulate natin siya as ARMA 11, but take note, this is simulation. So nung chinek natin yung time series natin, yung model, ang sinasuggest is an ARMA 22 model. So what does an ARMA 22 model look like? Okay. What does it look like? Apat yung components natin. So how do we write now our model? So yung natin, di ba? ARMA, call it ARMA 11, di ba? ARMA 11 at time t is equal to, so how will our model look like? Wala tayong mean. So that will be 1 point, copying ko na lang to para hindi ko na Control C, Control V. Okay, so that's times ARMA 11 t minus 1. Okay, diba? That's the t minus 1 component. And then plus negative of this times that's ARMA 11 t minus 2. Okay, plus epsilon sub t, okay, minus yung MA components, guys, we write it as mas minus, no, times epsilon sub t minus 1, okay, minus this is times epsilon sub t minus 2. Okay, yun. Ito yung model natin, guys. So ARMA 11, yung time series natin na create as a function of time, sub t yan, sub t, no? Is equal to, model natin 1.34 times yung object kasi natin, guys, ano, no, yung pangalan niya, ARMA 11. Okay? If this was y, magiging y sub t to is equal to 1.3409 times y sub t minus 1. Okay? Plus error term minus the error term at time t minus 1 minus the error term at time t minus 2. Okay? So that's our model, guys. If it was an ARMA 2.2 model. So sa take-home exams, you guys, group exams, I'm thinking of 2 or 3 per group. Siyempre, imo-model nyo, no? And you have to know how to write this in latex, no? So dapat yung sa printout ng PDF or HTML, dapat naka-sub to, sub t minus 2. Okay? Okay, dito nag-ano lang ako ng nag-create ako ng nag-create naman ako dito ng guys, ng simulate ng, ano naman to, 2-2 model naman. No? Okay, so I'll just leave this to you for you to work on. Okay, so we need to move on. Okay, ito na guys yung ano, yung this is similar to what we have been discussing so far. Ito, pinagsama-sama lang, no? So iba't ibang AR components to ARP. So this is a list 0.7, 0.2, -1, -0.3. So nag-create tayo dito ng ano ng object na AR mods, which is a list. Okay? List siya. Tapos paano mag-create itong ARIMA.mods na to? Okay? Yung ARIMA.mods based on P, no? So isa-simulate niya 10,000 na observations. List is equal to AR component is equal to yung ARP na object natin from 1 up to P, and then define niya yung standard deviation is equal to 1. Okay? I think we did this last time. So if we run this, so mag-generate siya ng list. Tingnan nyo, asa na si ARP. I-view natin si ARP. View AR mods pala ito. AR.mods. Okay? View AR.mods. Let's see what it contains. Yan, AR.mods. Okay, it's a list, no? It's a list consisting of 1, 2, 3, 4, apat na time series objects. Yung una dito, it's an AR process with A1 at 0.7. The second one is also an AR process, lahat to AR process with coefficients at 0.7, 0.2, -0.1, at saka -0.3. Okay? So tapos i-plot natin siya guys. Let's plot this. Ito, no? So we have four objects here. Partition MF row. Oops, sorry. Let's just wait for it to. So na siya. Yan guys. Hindi masyadong kita, no? Okay, here. All right, so this is the first AR1. Tingnan nyo guys yung ano, 0.8 something, ano? 0.8 something yung, wait, ano ba yung, ano, yung una natin? Hindi yan. The first, 0.7. 0.7 yung unang function, tingnan natin. 0.7 yung unang log. So ito siya. Ito guys, at 0 to no? So, correlation ng time 0 with time 0 is 1. Okay, ito yung log 1. No? So around 0.7, tama. Around 0.7. So dito siya, ACF yung una dito, no? So significant at first log 0.7. So tama siya, no? Tapos AR1, ito yung plot natin. Okay. Sorry, dito pala ako titingnan, no? PACF. So this is log 1. Ayun, no, 0.7. No? 0.7. Okay, sorry about that. This is an AR1 process, so dapat ang tinitingnan natin yung first, yung log 1, yung PACF. So slow decay sa ACF. Ito naman, this is around 0.2. Kita nyo guys, ano yung mga significant ano niya? This is 0.1. Okay. So mga slow decay siya sa ACF and significant log sa PACF. Okay, so that's just what I just wanted to demonstrate here. Okay, so na-plot natin. Okay na siya. Tapos inulit lang natin to dito sa ano sa Inulit lang natin sa na-close ko. Naghang sandali. Please don't wag mag-ano. Okay. Yan. Okay. Okay. And then ito naman MA guys, MA. Sige, run na lang natin din. Ganun din siya, no? Mag-create tayo ng, we're creating 4 MA coefficients. Okay, 0.7. Pareho din sa taas. MA model natin, it's a list. ARIMA.sim. MA model siya. No? Is equal to MAQ, which is this one. 0.7, 0.2, negative 0.1, 0.3. Okay, from 1 to Q. And then ito ipa-plot. Ipa-plot siya. Ipa-plot yung PACF at saka yung ACF. Partition, 4 rows and 3 columns. Yun ibig sabihin itong partition. Number of rows, 4. Number of columns is 3. Okay, so let's run this. Run natin si ma.mods. If you check ma.mods, guys, it's a list. And then ito, yung plot. Okay. So, okay, MA model to guys, di ba? Ang tinitingnan natin sa MA guys, yung ACF. Okay. So, this is at 0. So, of course, ang correlation ni data at time time 0 is time 0. And then this one is around point ano ba to? Point 8, 0.6, 0.7 something. Okay. Ito yung significant niya, no? And then sa PACF niya, it's slow decay. So once again guys, pag MA, ang tinitingnan natin yung ACF. So doon yung mga significant ano niya, lags. Significant spikes. Okay. Then sa PACF, they're all slow decay. So X ko na to. X natin to. All right. Okay, so summary lang to guys ng yung mga notes sa taas. Summary lang siya. Okay. So let's go here to line 421. Now we have what we call difference data. Kailan natin dinidifference yung data? Dinidifference natin yung data guys kung may trend. Okay, if there's trend, we have in order to make it stationary, we will have to difference. Okay, so kung walang differencing, y sub t is equal to y sub t. If my differencing, y sub t will be equal to, yung bagong y sub t natin will be y sub, yung original minus yung lag 1 na data. I'll illustrate this. Kapag second differencing, okay, so this is the first differencing minus y sub t minus 1 minus y sub t minus 2. So nakakalito, no? Okay, ang ibig sabihin lang nito, pag second differencing guys, ang gagamitin natin is not the original data, but the first difference data. Okay, let me explain that. Kasi ang hirap i-explain ng ano eh. ng okay. So na-discussion natin to yung yung AR1 process, no? Repeat na lang 'yan. Okay, ito guys, this is ARIMA 111. Ano ibig sabihin tong ARIMA 111? Okay, pag may 1 sa gitna, difference, ibig sabihin you're not using anymore the original data. Ang ginagamit mo na data, yung difference na data. Okay, kaya yung ARIMA 111 is you model the difference time series is equal to, you have a mean plus the coefficient of the difference t minus 1 minus yung coefficient na B1 ng epsilon sub t minus 1. Okay, so let's show that. Kasi ang hirap niyan ang hirap intindihin unless na magbibigay tayo ng example. Okay, so ano to? Small. Okay, take note guys ha. Coefficients of the AR1 and the MA1 can't be greater than 1 and it can't be less than -1. In other words guys, dapat yung absolute value niya should be less than 1. Okay, so what ito, hindi ako naglagay ng notes dito ha. M is equal to 1. Okay, so nagsasimulate tayo dito ng yung coefficient natin 0.1. Okay, small coefficient. Sige, i-run natin to guys. And then standard deviation ng model natin is equal to 1 plus M. Okay, so dito guys, nag-generate tayo ng time series. Simulate tayo. Ito, simulate tayo ng time series niyan. Tapos, we're going to add 1 to all the points. Plus M dito sa dulo. Okay, so let's run this and plot natin yung AR1 natin. Okay, what do you notice about something distinct ba? Wala naman, di ba? Trend, the same. No? Trend is this, walang trend, walang seasonality. And then kunin natin guys yung let's get the autocorrelation function. Okay, so sa PACF tayo. So dito, significant at the first lag, mga 0.1 something lang. Tapos dito sa PACF mukhang slow decay lang din. So this is a candidate for an AR1 process. Okay. All right. So what we're going to do now is we're going to forecast. Po-forecast natin yung time series natin. So di ba may time series tayo na okay. Minodel na ba natin to? Lagyan natin auto.arima. Sorry about this, kalimutan ko. AR1 dot small. Okay. Trace is equal to so let's see the ARIMA model for that. Okay, tingnan nyo to guys, no? It's an MA, wait. All right. So lumalabas na ARIM na siya ng MA, no? MA model. Okay, tingnan nyo ha. So nag 100 siya. Okay. 450. Pero mas maliit yung yung AIC ng MA model, no? Okay? So ang pinakamaliit guys itong ARMA 1 model natin. Okay? And the model is ito, 0.19 yung MA1 component at saka yung yung mean. Di ba nagdagdag tayo ng 1? Yan, no? Na-capture niya yung plus 1. Okay? So, what does this tell us, guys? I want you guys to research paano kung anong relationship ng AR model at saka yung AR1 model at saka MA1 model. Is there a relationship between them? There is a relationship between them, and I want you to lalagay ko dito ha. Discover, ano ba yung relationship between AR1 model and an MA. May relationship ba sila? Okay. Or in general, ano yung relationship ng AR model at saka MA model? Kasi dito guys, bakit kapag yung coefficient natin, yung phi1 natin is 0.1, okay? Kasi linis natin as an AR model to, di ba? Tapos my standard deviation is equal to 1 plus we gave it a certain mean, no? 1. Prinat natin, well, pag prinat naman natin yung mga stationary series, parang ang hirap ma-distinguish kung ano yung differences nila. And then di ba, nung prinat natin to, ano yung lumalabas? Lumalabas nga na parang ano din no? So significant siya dito at PACF, significant siya dito. Ganun din guys sa sa AACF. So parang it can go either way no? It can go either way na AR1 siya or MA1. Although sinet natin siya to simulate an AR1 process. Pero ang lumalabas parang MA1 din siya. No? So there's something about that small value. I want you to find that out. Okay? So I'll go here, guys. We can forecast our model. Okay, for example, we're going to use from the forecast package. Forecast natin using ARIMA, AR1.small. Ang pinapagamit natin yung AR1, then include constant is equal to true. So let's run this. Okay, dito naman guys, nung ginamit natin yung forecast package, ano lumabas? Lumalabas na AR1 model siya, no? AR1 model. So, what gives guys? Bakit magkaiba yung Bakit magkaiba yung model ni pag nag-auto.arima tayo? Kasi dito nung nag-auto.arima tayo, kinumpare pa nga niya itong ARIMA 100, 1450. Yung ARIMA 001 naman, 1448. With an AIC of 1448 na. Well here, hindi kasi nag-order tayo dito. No? So consistent nga siya. No? Kasi 1449.16 yung AIC niya dito. Dito, 14 point, medyo may konting difference. 1449 dito, 1450. Okay, but still guys, based on the Auto ARIMA package, mas magandang model natin is MA model. Okay, here we just use the forecast package and then function din to ARIMA. Okay, so ito naman guys, example ng large, yan, 0.9. So yung natin, yung phi natin, yung coefficient natin is, saan na siya? 0.9. Okay? So, what happens here? Just nagdagdag tayo ng 1, no? So, let's run this first tree. Run natin. Tapos, i-plot natin. Okay, you notice guys, pag mas malaki yung coefficient, what do you notice? Medyo mas mas lumalaki yung variation nila as compared to yung mas maliit yung AR1. Yung 0.1 lang. Bakit ganun guys? Kasi nga, yung predictor natin na yung coefficient natin, maliit lang guys yung ano yung component ng minomultiply natin sa log 1 na value. Ito 0.9. So halos pareho na ng y sub t natin. No? So para mas malaki yung what do you call this, yung volatility nitong model natin na to. And then forecast natin yung large na AR. Okay. So 0.846. Okay, AR1 yung lumalabas sa kanya. Okay, pwede tayong let's see, auto.arima tayo dito. Auto.arima. And let's see if AR1 that large is equal to okay. So, strange, no? Bakit ganito? What's this telling us? What's this telling us, guys? May na-notice kayo? Ang inaano niya dito, i-difference yung model, no? You difference the model daw. Okay, kasi this is already approximating 1. Diba? Remember guys, kapag 1 siya, kapag 1 na yung coefficient natin, hindi pa pwede. Okay? So, while if this is getting closer and closer to 1, what happens? What happens? Sabi nga natin kanina, parang nagkaka-drift na siya, no? Parang lumalaki yung yung fluctuations ng data natin. In fact, we said that if this was 1, kung 1 tong AR process natin, tapos i-run natin to. Okay, let's run this. What happens, guys? Yan. Hindi pa pwede, no? Hindi pa pwede kasi hindi na siya magiging stationary. Yung kanina, ano yun? 0.9, no? 0.9. So, halos malapit na sa 1 eh. Okay, and in fact, nung minodel natin siya, ang sinasabi, mag-differencing, di ba? Ito, which is strange. No? ARIMA 010. So it's suggesting that you difference the data. Okay, let's see what happens. No? So mag-insert tayo dito. Okay, so I'll call this D, difference AR1 dot large. And it's the difference of AR1 dot large. Ito guys yung function ng differencing. So let's see. Run natin. Naran ko na ba? Okay. So view lang muna natin guys. View yung AR1 dot large. So this is AR1 dot large, and then view natin yung difference AR1 dot large. Okay, what do you notice happened, guys? AR1 dot large. So that's -1. Ito yung una, di ba? Control C, Control V, and then we have this second one. Oops. Control C. This is the first one, Control X. Okay. So ito, guys, ang difference data will be yung second value minus the first value. No? Pag kinuha natin yung difference yan, negative 2.24 minus 1, negative 1.32, you're going to have negative 0.95, no? Which is now your difference data, negative 0.925. So ang difference, guys, pag nag-difference tayo, binaminus natin yung magkakasunod. No? Depende sa log. Kung log 1, this minus this, this minus this, this minus this. Okay? Yung magkakasunod, ima-minus natin. So, yung ano natin, yung AR1 na large natin, 500 entries, pagdating dito sa difference, 499 na lang. O, mawawala ng isa, guys, kasi nag-minus tayo. Minus natin yung dalawang values. Okay? So, let's see, guys. So, nag-difference tayo, no? Tapos, let's see kung i-plot natin. No? Plot. Screen natin yung natin to. Okay, stationary pa rin, no? And then yung AC niya, what happened? Okay, tingnan nyo guys, oh. Nung dinifference natin, parang naging white noise na siya, no? Naging white noise na siya, tapos check natin yung auto.arima. Auto.arima ni... Okay. Okay. Naging 0-0 na siya, no? Naging 0-0 na yung ano natin, yung parang naging white noise na siya. Okay, are you able to follow, guys? Nasundan nyo ba? So may intricacies, guys, kapag yung sa AR natin, kapag lumalapit na siya sa ano, lumalapit na siya sa 1, no? At saka kapag medyo lumalapit siya sa 0, kanina minodel natin yung 0.1 na AR, tapos ngayon naman 0.9 na malapit sa 1. Okay, and you notice, strangely, yung AR na component na na 0.1 yung phi natin, yung coefficient 1, it approximated an MA1 process, no? Naging MA1 process. Tapos ito naman si almost 1, yung 0.9. Ano nangyari? What happened, guys? In fact, lumabas nga sa 0.9 is ano eh, di ba? Hindi siya AR ano eh, no? Hindi siya AR1. Okay, but if we kung i-run natin as AR1 yun, no? Tingnan natin ha. Hindi, ito na yung ano, no? Yun na ba natin to? Ito na pala, no? A difference to. Ito yung original data natin na AR1. Ayan, lumalabas sa differencing daw yung ano, yung differencing daw yung model natin. Okay, so tapos nung dinifference natin, naging white noise na siya. Okay, so that's what happens when our model is yung phi niya very close to 1. In fact, sabi natin, if it's greater than 1, hindi mag-run to. Okay, if if our A1 is equal to 1, okay, if our A1 is equal to 1, then it becomes a random walk. This is a special kind of non-stationary. Okay, let's run this, guys. Yung AR1, AR11 natin. Tawagin natin siyang AR11. Simulate natin. Okay, AR is equal to exactly 1. Tapos plus M, may M pa naman tayo na object. Okay. So, alam natin guys na mag-error to, no? So, nag-error siya. Okay. Narana pala natin yung 1.01. So, it does not run, no? Kasi pag dapat yung ano natin, yung fee natin should be absolute value niya should be less than 1. Okay? So I think guys, I think medyo clear na sa atin yung yung mga AR process, yung MA process. Okay, punta na tayo dito kasi ito na yung we're running out of time. Gusto kong makapag-process tayo ng let's say ng stocks kasi ito yung ito yung take home exam, no? Okay, so using the quant mode package, guys, we can get symbols. We can get stock prices. I think we started discussing this last time. Ticker symbol ni Apple, and then let's get the prices from January 1, 2014 to December 31, 2021. Run natin to. So the get symbols, the quant mode package is a very powerful package for, let's say, getting sources, getting data from Yahoo Finance, from Fred, yung macroeconomic database ng sa St. Louis. Tapos, okay, sige, ano natin, no? So meron na tayong object na AAPL, yan. It's an extensible time series. Okay, i-view lang natin to just to show you. What's the difference between a data frame and an extensible time series? If you notice, guys, yung get symbols will give us this data, yung opening, high, low, close, volume, at saka adjusted price. And then you notice, guys, yung time, yung date and time, it's an index. It's not part of the column. So this is what distinguishes a data frame from an extensible time series or a zoo. Zoo din to, no? Zoo data, zoo or XTS. So yung dalawang to, zoo or XTS, these are time series. Tapos yung niya, special type of time series siya kasi yung label dito, yung index are dates or time, depende dun sa data natin. Unlike a data frame, guys, 1, 2, 3, 4, 5 lang yan, no? Number lang yan. Tapos yung data mo as part of your as a variable for your data set. Okay, ang XTS, guys, naka-index yung time, which makes it very, very convenient when we're dealing with time series. Okay, let's convert our big apple to AAPL. Okay, so I just called it AAPL. So pag tinignan ko tong, sorry. So we now have two objects. Yung isa yung AAPL, yung small. Okay, so structure, guys, will just give us the kung anong laman niya. So ito, it's an XTS object. Okay, so ang mga mga elements, mga variables siya, AAPL, open, high, low, close, etc. So it's index, ang index niya, time zone, UTC. Okay. Let's move on. Okay, so we will now model si Apple, no? We can use the closing, yung ibang ginagamit yung closing prices. Others would use the adjusted close. So for our purposes, for our model now, we're going to make use of the adjusted close. So kung gusto natin yung Apple object natin, gusto natin isang column lang yan, yung adjusted close. So let's subset. then pag i-check natin si AAPL natin, si isa na lang siya, no? Adjusted close na lang. And then we can change the column names, okay, ng Apple object. You make it adjusted. So if we run this, guys, tapusin na natin yung Apple dito. This one. Pinalitan na yung pangalan, no? Adjusted ng nakalagay. Kasi i-change it. Okay, so preliminary analysis natin, I think na okay, we can use the auto plot sa GG plot. Okay, so when we run this, ilagay lang tayo ng title, Apple closing prices from January 1 to December 31. Okay. And then yung Y label natin is daily prices. So let's wait for it to run. Okay. So ito guys, yung Apple natin definitely hindi siya may trend siya, and may trend parang yung quadratic yung trend niya, no? Medyo pa-curve na ganyan, hindi line. And also, there does not seem to be any seasonality. Mukhang wala naman seasonality siya. Okay, so therefore guys, hindi natin basta-basta pwede i-model to sa box Jenkins. No? Kailangan i-convert muna natin. Okay, so this is another way to plot. Another way to plot. Yung chart series ng quant mode. That's a very good plotting tool. So just to show that the data is not stationary. Okay, so anong gagawin natin guys? How do we now convert our time series into, paano natin i-differentiate? Just like what we mentioned a while ago, differencing guys, okay? So sabi natin dito, no? Convert our Apple time series to stationary time series by getting the first difference. Getting the difference will remove the trend. Okay? So ano yung difference sa data series? 'Di ba mina-minus siya, no? Depende dun sa lag. Okay, pag differencing, tingnan natin lag, may lag ba 'to? Okay. Yan, meron. Mamaya na lang. Let's just assume that isang differencing lang to, no? So, DAAPL, difference Apple is the diff function. Enter natin. Okay. So, let's view now. Ito si Apple, di ba? Si Apple natin yung adjusted prices na to, closing price. So, what will happen if we difference this? Ima-minus niya. Let's guess, no? Sige, gawin natin. So, difference Apple, meron na pala, no? So, ito na yung difference Apple natin. Yan, tingnan nyo guys, no? Minus na niya. Okay, so that's 17.13 minus, minus 17.51. So, that's around 0.3 daw, no? 0.3. Ayan, negative 0.3 kasi mas mataas yung first period. Okay, so now this is the difference series. Yung Apple series natin, 2000, ilan siya? So length ng AAPL. So 2014, tapos length ng difference ng AAPL. Okay. Marami ko na ba yung DAPL? 2014 pa rin guys. Bakit? Kasi sa difference natin, yung first element dito NA. Okay, so dapat tanggalin natin siya. Okay, so the new DA difference Apple series will now be DAPL, and then i-subset natin, subset natin, tanggalin natin yung first row, and then since isa lang naman yung column that will remain. Okay, so we take a look at the new DAAPL. So tinanggal na natin yung ano, no? Tanggalin yung first row. DAAPL. Yun natin yung length niya, length. (2013) na lang. So 2013, nag-update na siya. Okay, so let's move on. Then i-plot natin guys si DAAPL. Tingnan natin kung ano nangyari sa kanya, no? There. Okay? So tingnan nyo guys, no? When we difference, what happens is tinatanggal niya ano, tinatanggal niya yung trend, no? It removes the trend. Okay, I just want to explain something. Let me just put it here. Sandali, ah. Ano naman guys yung second differencing? What's the second differencing? DDAAPL. So let me create another object, DDAPL, okay, which is the difference of your DAAPL. So what's this, guys? What's this? Pag second differencing, ang ginagamit natin guys, yung difference, no? Magma-minus ulit tayo dito. So 0.09 minus negative 0.38, so that should be around 4.7. Kasi positive minus negative, around 4.7 to. Okay, so i-run natin itong double differencing. I-view natin siya, DDAAPL. Diba? 4.7 something as I said. No? Tapos tatanggalin ulit natin yan. So that's what we mean by second differencing. Eh, iba kasi nalilito pag sinabing, akala nila pag second differencing, this 17.22 minus 17.51, hindi. No? Pag nagsa-second differencing tayo, ibig sabihin, we difference the difference data. Okay, ito yung difference data natin. Ito yung original data. Okay? Difference data ito. Second differencing ito. Okay, of course, tatanggalin natin yung isang object na NA. Alright, so just to clarify, pag second differencing guys, you difference the difference data. Okay, now ito naman guys, ano to? Sabi natin dito, okay, what would have happened if we got the log of the series instead of differencing it? Okay, anong ginagawa ng ano guys, if you get the log of the data? Tingnan natin ha. Log ng Apple is equal to log Apple. So we're creating an object called log of Apple. Okay, asa na si view nga natin. Log Apple. Alright, yan. 2.83. Samantalang yung Apple natin kanina, okay, 17.51. Okay, so what does this tell us? Ang kainaman guys, ng pag dinolog natin yung ano natin, yung object natin, kunwari itong log ng Apple guys, nasa scale yung data natin. And this is particularly true if you're dealing with economic data or financial data, kunyari GNP, GDP, which runs in the millions, depende sa kunyari sa country. So it can run into billions, no? So it's really very difficult to handle very big data. So ang ginagawa usually yan, linolog yung data natin para nasa-scale siya. Okay? Nasa-scale yung data natin. So when we logged it guys, ano nangyari? I-plot nga natin. Okay, take a look at this guys. Okay, nung linawag natin, hindi na cure yung ano, hindi na cure yung yung trend. May trend pa rin siya. Okay? So there's still a trend. So getting the log did not make the series stationary. Naging linear lang siya. No? Hindi, kanina parang quadratic eh. It made it more linear but it did not address the trend. Okay? Hence guys, kung may trend yung data, you get the difference. Okay? Not necessarily, okay lang guys, kunin din yung log. Especially kung malaki yung mga data. No? Sabi natin, pag malaking data natin, usually talagang linolog yan. Pati sa pati sa returns guys, prices, returns. Okay, usually sa finance guys, yung minomodel diyan, yung inaaral, yung returns ng stocks. Okay. So ito naman, okay, so here what we're going to do is we're going to get the difference of the log data. Okay? So will this make the data stationary? Tingnan natin ha. Ano mangyayari dito guys? Difference ng log data. Let's see what happens. Okay. So this is now the difference of the log data. So kinuha muna natin yung log, tapos kinuha natin yung difference. Okay? Okay, where are we now? Okay, gusto kong umabot tayo sa modeling na para okay. So getting the log of the difference data. Okay, may isa pang concern dito, no? Okay, so what did we do here? We first got the log. Kinuha mo natin yung log. Tapos pagkakuha natin yung log, kinuha natin yung difference. Take note guys, nung kinuha natin yung log ni Apple, no? Log ng prices ni Apple. Ito yun. Ito yung si Apple. So positive value siya. Positive value siya. So hindi natin pwedeng kunin guys yung log ng isang negative number. For example, this one. So ito naman, kinukuha natin yung log ng difference data. Di ba yung difference data natin guys, may negatives yan, di ba? Okay? So if we get the difference first and then ilog natin, ano mangyayari? Tingnan niyo ito. Okay? Mag-e-error tayo guys. Kasi hindi pwedeng magkumuha ng log. Tingnan nyo ha? Log ng negative 10. Okay. Hindi pa pwede. No? Okay. Ang range ng log lang guys is log ng 0. Pwede ba? Okay. Hindi rin pa pwede. So you can only get logs of numbers na positive na 0.1. Log of 0.1. So compute pa. So you cannot get the log of negative numbers. Therefore, hindi natin siyang pwedeng i-difference tapos kunin natin yung log. Okay, if you need to do both, if you need to difference it, if you need to get the log and also differencing, kunyari, GDP yung tinitingnan natin, no? Tapos may trend siya. So anong gagawin natin para gawing stationary yun? Kunin nyo muna yung log para ma-scale, tapos saka nyo i-difference. Hindi pa pwedeng i-difference, tapos kukunin yung log. Why is that so? Kasi pag nag-differencing ka, possible na may negative number dyan. Okay? So hindi mo na pwedeng kunin yung log. So what you do is to get the log first. Kasi kunyari GDP, ang mga positive numbers yan, di ba? And then you get the difference. Okay. All right. So, saan tayo dito? Okay. So clear tong guys yung yung pag kailangan mo i-log at saka difference, Okay, get the log first and then get the differencing, and not get the differencing first and then get the log, kasi magkakaroon ng negative values yung differencing natin. Okay, tapos pag ilog natin hindi na pwede. Okay. So getting the log, guys, will linearize your data. And there are other ways to linearize your data. Maraming ibang ways kung kailangan nyo i-linearize yung data. So you can refer to this. Magandang reference to on how to linearize your data. Okay, now question. So gamitin natin, guys, si difference AAPL, no? So wag na natin siya ilog, yung difference na lang. Kasi maliit lang naman yung mga values yan, 17, no? 17, 18, etc. So let's check first if the difference data is stationary. Stationary ba to? Let's check. All right. So sabi natin, ang null hypothesis nito is not stationary, no? Okay, so our p-value is 0.01. So we reject the null hypothesis that our time series, yung difference na apple returns, is not stationary, no? It is stationary. Okay. So stationary yung prices natin, no? Okay, so another test lang yan, huwag natin kunin yan. This is also another test. So I place here a different test for stationary. Dito yung URCA, no? Yung unit root DF test. And itong KPSS test. Okay, suotin natin to. Let's check. KPSS test for trend stationarity. P-value is 0.1. Okay, so ang ano dito, ang si KPSS test, ang null hypothesis niya, the time series is stationary. Baliktad siya ng ano, no? Baliktad siya ng ATF test. So since the p-value is 0.1, then we reject that null hypothesis that we fail to reject the null hypothesis that the series is stationary. So indeed it is stationary. Okay. Okay, so tapos na tayo dyan, guys. Tingnan natin yung ano, yung autocorrelation function ni Apple, no? Difference Apple. Okay. So parang MA siya na ano, na may mga significant spikes sa first dito. So it's indicative na AR to, no? Tapos dito din significant dito. So significant na malamang baka ARMA to, no? Using the ACF and PACF, pwedeng ARMA yung modeling ng ano natin, ng DAPL. Okay, by the way, guys, take note, ang minomodel natin dito yung ano, yung price ng Apple. Okay, usually ang minomodel yung returns. Yung returns ng stock natin. So madalang, guys, na ang minomodel natin yung prices mismo. Although I've seen some researchers that model the price. Ang kadalasan, guys, ang minomodel yung returns. So dapat yung returns ang i-compute muna tapos saka i-model. So sa ano nyo, sa take home quiz, ang i-model nyo yung returns, ha? Okay, so just to illustrate to you here, guys, kung ang minomodel natin dito yung, okay, to use the ARIMA, sandali, ha? Okay, ang question dito, guys, anong gagamitin natin sa modeling? Yung DAAPL or AAAPL? Okay, you can use both, guys. You can use both. So, pwede mong gamitin yung difference na data, okay? Or pwede mong gamitin yung original na AAPL na data. Okay, let me illustrate. So dito, guys, model 1 natin, auto.arima, yung difference na data natin. So let's see kung ano yung model na to. Ano yung sinasuggest na ARIMA model here? Okay. So, so we can see here guys na saan na yung result? Okay. It's an ARIMA 510 model. Ano ibig sabihin nun guys? So AR component 5. Okay, tapos i-difference mo pa. So ibig sabihin guys, dapat dalawang differencing ang gagawin natin sa ano. Kasi ang ginamit natin dito yung difference na data na no? Difference na Apple series. So ibig sabihin, we will have to difference again, okay, difference again, and then ito yung mga components niya. Okay, so medyo very tricky guys yung ano natin, no? Yung how do you now write the model? Okay? So how do you now write the model? Kasi iba na guys pag difference yung data. Take note guys, ito yung Apple natin, di ba? Ito yung Apple natin. Ito ngayon yung asan yung the Apple natin. Wala, tinanggal ko. Difference AAPL. Okay, so this is our difference AAPL. Ito na yun. No? Okay, tapos ang sabi, mag-ano pa raw, mag-differencing pa raw niyan. Di ba nag-double differencing na tayo? Asan yung DD? Okay, gawin ko ha. Sabi doon sa model, ARIMA 510 of the difference model. Ibig sabihin guys, again, i-difference ulit natin yung my first differencing. So ibig sabihin, dalawang differencing dapat ang gagawin. No? Asan yung difference natin dito? Si DDAPL. Ito. Si DDAPL. No? Okay, and ang gagawin natin dyan, tatanggalin natin yung DDAPL. We will remove the first one. Oops. Sorry, mali. DDAA pala. Apple, DDAPL. Okay? So, tingnan natin DDAPL natin. DDAPL ito. Okay, so nawala na yung no? Nawala na yung ano natin, nawala na yung negative natin. So how do we write this model, guys? How do we write this model? So ang model natin ngayon, yung hindi na yung original, di ba? We're now looking at DDAPL. So how do we write this? DDAPL at time t, okay, it will be equal to, so ano yung result natin? What was our result? Ito yun. ARIMA 510. Take note, ang minodel natin ito difference na Apple series, no? So sinasabi niya dapat magdi-differencing pa. So another differencing, so that's called DDAAPL, no? DDAPL at time t is equal to negative, copy natin to, Control C, Control V. So lahat to guys AR component, no? Negative 9.106 multiplied by, okay, difference na to guys, ha? Control C, Control V. So that's a difference T minus 1. Okay, so ang minomodel natin ngayon guys, yung ito now is based on the double difference na Apple na data, no? So this is also, copy na lang natin to. Control C, Control V. Copy ito. Control C. Control V. Control V. So our model now is T minus 1 and then T minus 2 and then T minus 3 and then T minus 4 and then T minus 5 plus an error term. Okay. Yan na ngayon yung model natin, guys. It's now the double difference na apple. Okay. So itong mga components na to is now based on this data. Yung double difference natin. Okay, I hope that's clear, guys, no? Double differencing tayo dito. Tapos yung mga AR components natin, okay, should be based on our data. So mode 1 natin yon. Tapos tingnan nga natin, guys, yung ano, yung I hope, guys, nakakasunod kayo sa'yo, nakakasunod kayo, ha? Okay, tingnan natin mode 1, residuals. Tapos kunin natin yung AC nito. So yung model 1 natin, this is your difference, double differencing na ano na may second differencing na apple. Okay? Kinuha natin yung residuals niya, tapos tingnan natin yung ano yung autocorrelation ano niya, tingnan niyo. Is it white noise? Yeah. Okay, ang problema dito, guys, may mga significant pa, no? Okay, may mga significant lags pa. Okay? So this is indicative, guys, na hindi pa niya nakaka-capture lahat, no? Hindi niya nakaka-capture lahat. So what does i-plot nga natin yung ano? Ito na yung ACF niya, no? Let's see. How does the plot mode 1 residuals? Alright, tingnan nyo, guys, no? Stationary ba yung ano natin? Stationary, wala namang trend, eh? Tsaka walang trend, at tsaka walang seasonality, no? Ang problem dito, guys, tingnan nyo to. Hindi constant yung variance. Ibig sabihin, heteroscedastic siya. Okay, kasi tingnan nyo, may mga portions dito na ano, may mga portions dito sa ano natin na, okay, na grabe yung ano, grabe yung shocks, grabe yung volatility. So dito, ano lang, maliit lang volatility. Pero pagdating dito, baka ito yung global financial crisis. Ano ba yung, ito 2014, no? So baka dito, I'm just guessing, baka, ano ba yung date na ginamit natin? Okay, anyway, baka dito yung sa ano, yung sa COVID, no? I don't know, I'm guessing. Okay? So, yung plot ng residuals natin, hindi constant yung variance. Okay, which is heteroscedastic, no? So, ang ibig sabihin nito, guys, nakuha na nating ARIMA component pero hindi pa rin kaya. Okay, which tells us that there must be another model for this. Doon papasok yung next lesson natin, guys, na GARCH. Okay, kasi may mga time series, lalo na, guys, lalo na yung mga returns, yung mga prices, yung mga stocks, no? Kasi napaka-volatile niyan. So usually an ARIMA model will not be enough. Okay? You will have to model also the volatility because ARIMA model will not be able to capture this volatility. So siguro makakapag-introduction tayo ng konti doon, no? Pero tapusin muna natin 'to, no? Okay. So I hope clear yun, guys, no? I hope clear. Okay, now, ang ginamit natin kanina, yung difference na AAPL. Actually, pwede niyong gamitin yung original. Okay? So dito, nag-auto ARIMA tayo, no? Ito yung ginamit natin kanina, DAAPL. Here, let's create a model 2, auto.arima. we're using the original data series. Okay lang yun, guys. Di ba hindi stationary yung data series? Okay lang, bahala na si R magsabi kung may i-difference doon. No? Okay, tingnan natin ha. Let's run this. Okay, let's see what happens. Okay, tingnan nyo guys. No? Ano sinasabi niya? ARIMA 5, pero second differencing ka. So ibig sabihin, ang gagamitin natin na series is data si difference na apple, tapos isa pa ulit differencing, yung ginawa natin kanina. Okay? So it doesn't matter guys kung anong gamitin niyo na na model, no? Na kung yung difference ba or yung original na mismo, original na data mismo, yung AAPL. It will yield us the same answer. Ito ginamit natin si AAPL, yung hindi pa na difference, pero sabi niya, ang best model dyan, mag-differencing ka. ARIMA to, no? Yung integrated dito is twice differencing. Ano ibig sabihin twice differencing? I-difference mo muna, so magka-create ka ng panibagong isang bagong data series, tapos yung difference data na yun, i-difference mo ulit. Okay? So I hope that's clear, guys. Pasensya na mali ito ha. This is wrong, no? I think I used a different data set before. Okay. Alright, sige. You can predict guys. So predict, no? Predict natin, we can use the predict function, mod 1, and then 22 days ahead. Tingnan natin ha. So that's ito yung prediction. Kita nyo to here? Yan o. Nag-prediction ng 22 days ahead. So if we call this, let's call this object predict pred. Oops. So na siya. So nag-create tayo ng object na pred, no? And then let's see ano ba yung laman ng mga pred object natin. Okay? So ito, no? Ito. Pati yung standard error. Yun yung dalawang ano niya. So we can predict using our model. Model 1 kasi natin yung ARIMA 552. We can predict that. Or we can also use the forecast function in the forecast package. So here I'm creating future value 1 object using the forecast model 1, 22 steps ahead. Tapos gusto natin may 99.5% confidence level, and then i-plot natin. So let's see. Okay, hindi masyado makita, ano? Yan. Okay, ito guys yung predicted values, no? And the 99.5% confidence interval. Okay, but we can access those predicted values. Okay, sige. So para matapos na natin to, no? Okay. So here, I think ginawa na natin to kanina, no? Ginawa natin to kanina. Yung model 2 natin. Okay. Shortcut lang natin to, no? Mas madali yung AC. Model 2 residuals. Max that lang. Okay. Di ba may model 2 tayo? Tapos, kunin natin residuals nun. And then, yung print natin yung autocorrelation function. Okay. So, again guys, ito yung napakita natin kanina, no? So, ARIMA 5 na yan, siya na yung pinakamaliit na ano na AIC, pero meron pa ring mga significant spikes. And this is due to the di ba ginawa natin yung prinat natin yung ito because of the spikes here, no? Yung mga spikes dito ng variance natin, ng volatility. Okay, so okay na yan, na-plot na natin yung ano. So these are just different ways, guys, these are just different ways to plot. Okay, tapos lastly, natanggal ko yung best dot model. Nabulo ko yata yung best dot model dito, no? Hindi ko na-identify yung best dot model. Okay, anyway, let's just skip that. So, ayun, hindi ko, ginawa ko sa best dot model dito. Walang best dot model dito. Model 3 ako. So, model 3 ko. Unfortunately, guys, I think when I transfer this to another, ano ginawa ko dati dito? I'm sorry, kasi nagkaroon ako ng model 3 which hindi ko na-specify dito kung ano yung model 3 ko. Ayun, no, nagka-model 3 ako dito which I didn't specify which. Okay, tapos hahanapin ko siya, guys. Pati itong gumawa din akong best dot model. No? Then isa-send ko na lang sa canvas natin yung. Okay, and then guys, anong model to? Res. Gawin nga natin to. Okay, here you're testing the autocorrelation of the error terms. No? Ano yung res object natin? Residuals to ng anong model. Hindi natin kasi rinan yung iba dito. No? Okay. Can you tell me, guys, ano yung res object natin? Res. Where's res? Nag-create tayo ng object na res which is ito to. Wait. Residuals ng best model. Hindi naka-identify yung best model. Pero kanina kasi nag-create din ako ng object na res. No? Okay, anyway, sige. This guys, ito magte-test ng ng autocorrelation. Okay, importante yan guys sa time series modeling natin. You have to test for autocorrelation and you have to test for normality of the residuals. No? You can use the Shapiro Shapiro test to test normality. Okay, so that ends, guys, our discussion on ano ito? On ARIMA, no? Okay, so it's very easy now to model. So ano yung briefly, guys, ano yung mga steps? Pag nagmo-model tayo ng time series, kailangan muna i-plot natin, of course, that's the first step, plot, and check if the data is stationary. If it's not stationary, we have to transform the data. Either magdi-difference ka, pag malaki yung data, guys, i-log nyo muna, tapos i-difference. Then once you do that, i-plot ulit to check if there's stationarity, and then i-check statistically using ADF, yung augmented Dickey Fuller test, kung stationary na talaga. After that, saka lang i-draw yung ACF, PACF to indicate as a potential model kung AR or MA siya. Okay? Pero ngayon, guys, i-drawing nyo pa rin yung ACF, PACF, and then kunyari sa exam nyo, sa take-home, i-indicate nyo based on the ACF, possibly ito yung model. Okay, and then you model it now, and then you write the model, check again for residuals, look at the AC, okay, check the residuals, check the autocorrelation, and then check for the normality of the residuals. As much as possible, dapat normally distributed yung residuals. Okay, so that ends our discussion on time series. Now let me just quickly introduce yung sa GARCH. Hindi natin matatapos to. Pero at least, guys, let me just close this. Kindly open the GARCH RMD file that I shared with you. Okay, this one. So very quickly, guys, simulan lang natin kasi it's almost time. Okay, we'll just start. Okay, GARCH stands for Generalized Autoregressive Conditional Heteroscedasticity. Okay, kanina, guys, yung model natin ng AAPL ng Apple, kahit na ARIMA 520 siya, okay, ARIMA 520, ibig sabihin, yung AR 5 lags of itself, pero i-difference natin ng 2 times. Ibig sabihin, we're not using the AAPL data, we have to use the double difference na data. Okay, pero guys, nung tinat natin yung residuals, hindi heteroscedastic eh. Kasi may mga volatility clusters kung tawagin natin. So how do you address that? That is a signal that you have to move further from ARIMA to GARCH. So hindi sufficient yung ARIMA to model it. Unlike, naalala nyo yung nag-simulate tayo, tapos minodel natin, and then we plotted the the residuals. Kunyari yung naalala nyo yung A1 at saka yung M1 na objects. When we plotted the residuals, kita nyo white noise na eh. So okay na yun. Pero yung Apple natin, kahit na nag-ARIMA 5.2 pa, yung volatility niya hindi na capture. No? Sinumplinat natin yung residuals, may mga volatility clustering. So let me just introduce, guys, sa GARCH, gagamitin natin more, in particular si RU GARCH. No? Gagamitin natin yan. So i-run natin to. And here I'll tell you how to compute for the returns kasi dito ang imo-model natin yung returns. No? Okay? So GARCH is a way of modeling yung volatility na hindi nakakaya ng ARIMA. No? They're useful in situations where volatility of a time series is a function of previous levels of volatility. Okay? Ang tawag ng volatility clustering. So ibig sabihin, nagkakaroon ng spike sa volatility, maapektahan yung susunod, no? Kaya nagka-cluster sila, kaya nakikita natin yung plot natin kanina, may mga periods na ang tataas ng spikes. Okay? So So mali to, dapat may squared to, no? So ang minomodel natin dito guys, yung yung volatility. So dapat yung variance, yung sigma squared to. Kulang ng ano dito, kulang ng ilagyan natin dito ng caret 2. Okay, there. So what we're modeling guys is volatility, yung variance. So ang equation is equal to omega, this is a mean, plus alpha 1 times error squared, past value ng error squared, plus beta 1 times past value ng ng volatility. So ang minomodel natin dito yung volatility at saka yung error squared. Okay, parang MA siya, no? Pero yung error hindi t minus 1. Yung error the error is squared, no? Squared yung error. And then of course yung variance ng previous value t minus 1. Okay? So ayan yung equation, and you can look at this, no? You can look at this for the equation. Then if you want tips on how to do this yung latex na latex, you can use this site in order to produce these equations are markdown. Okay, so quickly now guys, ulit natin, quant mode tayo, get symbols, Apple, from 2008, January 1 hanggang December 31, 2020. Okay, let's run this. Okay, ilatan natin para sabay-sabay. Ito na natin yung result. Okay. Alright. View, ito yung Apple prices natin. Okay, parang kanina din. And then yung class, ano ba yung class ni Apple? Ito, it's an XTS object, extensible time series. So what's special about the extensible series, sabi ko nga kanina, is that the time is indexed. Later on, pag nasa research na kayo, baka time series yung gagamitin nyo, most probably. So makakatulong talaga to, no? Okay, class, and then yung plot natin ito, okay, there, yung plot. Tapos ito, nag-focus lang tayo, zoom lang natin sa sa December 2020, right? Okay. Now, ito yung kailangan natin, yung daily returns. Kasi ang minomodel, guys, usually pag nagmo-model tayo ng prices, it's the volatility of the returns, no? Hindi yung stock price mismo. So we're going to create an object called Apple Ret, no? Apple Returns, and this is coming from Performance Analytics, another very powerful package. And then ito guys, no? Calculate returns. Okay? Calculate returns. Tapos, ang kukunin natin, yung adjusted price lang ni Apple. Okay? Adjusted price ni Apple. Tapos, ang ano natin, method is equal to log. Gamitin natin guys yung log. Kasi di ba usually ang ginagamit sa pag-finance, log prices. Let's see kung... Okay, Apple Ret, yan. Let's try to see. Alright. So ito na guys yung object natin, ano? Apple adjusted, tapos ito na yung returns. So number 1, tanggalin natin yung unang ano ba ako? Yan. View. Tapos tanggalin natin yung unang row kasi may NA siya, no? NA. Okay, if you take a look at Apple Ret, wala na siya. Tapos tanggalin din natin yung, palitan natin yung column name. Sige. Call names ni AAPL Ret. Alt minus. Let's see. Gawin natin ano na lang, log ret na lang, no? log returns. No? Put okay, so si AppleRet, lagyan natin yung pangalan ng, gawin natin logret. Okay, let's see kung nagbago na siya. Yeah, log returns na. Okay, just a few more minutes guys para makaano lang tayo dito. No? Okay, tingnan natin guys yung plot ni ano. Okay. Look at the returns guys, no? So si returns mukhang stationary, no? Stationary siya, however, may mga volatility clustering tayo dito, no? Dito sa mga points na to. Okay, yung volatility natin dito masyado matataas sa mga may mga periods na to, no? That's what we call volatility clustering. So perfect to for a GARCH model. Kasi si GARCH ang minomodel din not only the yung ang especially minomodel niyan yung volatility. Okay, kaya nga ang tawag guys, a generalized autoregressive conditional heteroscedasticity. Autoregressive, which means yung past error terms niya squared, and then conditional heteroscedasticity, yung past variances niya. No? Eh, ang variances, alam natin, squared yun, sigma squared. Ito guys, going back to the equation here. Ano? Yan. Autoregressive, past error terms, bali MA squared, at saka yung variance niya, past variance. Okay, so, okay. Alright. So ito histogram lang natin. Histogram. Okay, so kita natin dito may mga tails dito, no? So hindi talaga siya normally distributed, no? May mga long tail siya. Tapos we can plot this yung chart that histogram. Okay? Yan, kitang-kita natin hindi siya normally distributed. Long tail, haba dito. Okay, so clean up na natin. Okay, let me just show this to you and then we'll stop here. Okay, so yung volatility guys, di ba, mini-measure din yan ng standard deviation. Okay, variance or standard deviation. So let's get the standard deviation of our object, Apple returns. Okay, it's 0.02. Kaso, yung data natin guys daily, no? So how do we convert this into annualized data, annualized volatility? So we multiply it by the square root of 252 kasi 252 trading days. Pag variance ang hinahanap natin times 252 to convert your daily variance into annualized siya. So pag standard deviation, square root of 252. So let's do this. Okay, 0.32 ang for the whole period ng Apple Ret natin from 2008 no hanggang 2020. Now tingnan natin guys yung standard deviation ng 2008 ng global financial crisis. Okay, you'll notice here 0.58% yung standard deviation. Okay, compare niyan sa 2009 okay, 0.34, so mataas no? Parehong years na kasi yung global financial crisis talagang ang laki ng fluctuation ng returns ng Apple stock. Compare that to 2019, 0.26 lang. No? 2020 okay, mataas din no? Most probably this is because of the pandemic, yung coronavirus natin. Okay? So the standard deviation over the complete sample can be substantially different, okay, from the standard deviation on the subsamples. So that explains why grabe yung volatility guys. May mga portions na grabe yung volatility. No? Kita natin yan sa yung pinat natin kanina. No? Here, plot Apple returns. Okay. Ito yung sa 2008 to 2009. Okay, so ito yung sa 2009 2020 malamang to. So may mga spikes tayo dito which ARIMA cannot explain. So that's why we have to use GARCH. Alright? So ito, pakiplot na lang kasi another way to measure volatility is yung rolling performance. Yung rolling performance, ito 22 days. So ano to? So monthly to. Ang ibig sabihin niyan guys, kino-compute yung volatility for 22 days. So may volatility ka for the first 22 days. Tapos mag-move ng isang day, the second 22 days, third. So yun ang tawag ng rolling performance. So pwede ding 66 days, that's isang quarter, or pwedeng 252, isang year. So I just compare nyo lang guys yung volatility nitong tatlo, no? Yung rolling volatility. Of course, habang tumatagal yung pag-compute ng standard deviation, parang mas nagiging mild yung run ko lang to. Medyo matagal siya. Tapos okay, lastly guys, ito na lang ha. Guys, pwedeng one last minute bago tayo mag. Okay, i-auto ARIMA natin. Nag-run pa rin, ang tagal niyan eh. Okay? So subukan nyo guys i-model yung Apple return. Okay, mag-auto ARIMA tayo. Tapos tingnan natin yung autocorrelation. Tingnan natin kung kaya na ba siya ng ARIMA model. Ang ibig sabihin ng kaya guys, pag print natin yung residuals, white noise na siya, no? Skip ko na lang to. Kayo lang bahala guys mag-plot niyan. Okay, so i-model lang natin ng ARIMA. Okay, let's call it FIT1 auto.arima yung Apple returns natin. I-trace din natin. Notice guys, ni-approximate lang niya. No? Itong pangalawa na to guys, yung auto.arima din, pero approximation is equal to false. Mas comprehensive na yan. Mas comprehensive na pagsubok sa pag-list ng ARIMA, possible ARIMA models. Okay, let's see. If you need to leave guys, you may, last 2 minutes lang to. Tingnan natin kung ano yung ARIMA na ibibigay niya. Okay. It's taking some time. Okay, and then dito ang gagawin natin, okay, tingnan natin yung residuals. I-plot natin yung residuals. This is another way guys to run I'll not run this, pero ito, approximation is equal to false. Ibig sabihin, hindi niya i-approximate. So mas mas maraming pwedeng ibigay niya na possible models. Come on. Ayoko. Natapos ba niya? Hindi niya natapos. Okay, one last. Hindi ko na iralan itong pangalawa kasi mas matagal yan. Okay, tingnan natin itong autocorrelation. Ano ba lumabas na model? Hindi pa tapos. Tagal. May lumabas yung model nyo guys. It's taking some time. Last na, ay pang naghang pa. Skip na lang. Okay, anyway guys, if you run this, yung autocorrelation niya, ng model 1 natin, tapos yung residuals ang i-ano natin, i-ano nyo, i-plot yung residuals. You will see guys na ano na yung autocorrelation niya parang yung kanina, yung Apple kanina na hindi white noise. Okay, and then if you plot the ayan, naghang na guys. Naghang na siya. Anyway, so I cannot run this kasi ayan. All right. So let me end there, guys. Kindly look at the autocorrelation function ng residuals ng FIT1 model natin. Okay, kung ano man yung lalabas dito na ARIMA model sa auto.arima. Check the residuals. Okay, get the autocorrelation function. And then makikita nyo sa autocorrelation function kung white noise na ba talaga yung ano natin. Wala nang significant correlation among the past values. Okay, most probably guys, may makikita kayo na may mga spikes dun sa ibang periods. Okay, and then it indicates that maybe hindi kaya ng AutoArima. Pag i-plot nyo yung residuals guys, yan siya. Pag i-plot nyo yung ano yung residuals guys, you'll notice na may mga ano talaga, may mga volatility clustering. Okay? So we'll continue with this next meeting next Tuesday. So next Tuesday, tapusin natin tong GARCH, tapos mag-ano tayo, mag-panel data. And I'll see kung I'm thinking mag-ano tayo, mag-SEM, no? Sa last ano natin. Okay, I'll post the group quiz sa Canvas natin. So it's due on Friday next week. There are actually two group quizzes tayo, isang time series at saka GARCH. Tapos yung isa dun sa previous topic natin. Okay, so thank you so much guys. Thank you for your patience. Stop recording.